In this problem, we're asked to find the probability that in the long run it's going to rain or be dry on a given day. And so in this particular environment, we know that whether or not it rains on one day is dependent upon whether or not it rained the previous day. So as it says, there's a 25% chance that if it rained on one day, that it will rain the next day, which tells us there's a 75% chance that if it rained one day, it'll be dry the next day. Similarly, it tells us that if it was dry one day, that the next day it will also be dry, which tells us that if it was dry one day, it will rain the next day 50% of the time as well. And so that's where we get 0.5 and 0.5 and 0.25 and 0.75, because remember, these rows always have to add up to 1, as these are the only two options for what the weather can do the next day. And so now what we want to do is figure out what the long run is going to be. So what portion of the days it's going to rain and what portion of the days it's going to be dry. So to do that, we're going to take T, P equal T. And so our initial matrix is P, and we're going to multiply that by some initial vector of just T, so it's an arbitrary vector, and it's going to come out equaling the same vector. So to figure that out, we're just going to let T equal T sub 1 and T sub 2. And we have a 1 by 2 vector here because we know it has to be a row vector, and it's a 2 by 2 matrix that we're multiplying it by, so that means we have to have 2 columns there. So what this is going to end up looking like is T sub 1, T sub 2, times our matrix P, which is 0.25, 0.75, 0.5, 0.5, and that's going to equal T sub 1, T sub 2. So now all we're going to do is multiply this matrix by this matrix. We multiply T and P, which is going to give us 0.25 T1 plus 0.5 T2 in our first entry, and our second entry will be 0.75 T1 plus 0.5 T2, and that will still equal T1, T2. And so now we're just going to write this as a system of equations. So obviously, for these to be equal, this entry has to equal this entry, and the second entry here has to equal the second entry here. So we're just going to write this as 0.25 T1 plus 0.5 T2 equals T1, because we see this one has to equal this one, and 0.75 T1 plus 0.5 T2 equals T2. And the other thing that we know is that T1 plus T2 is going to equal 1, and that's because, again, we have a probability of 1 for this, because we're really trying to find out what the probability is going to rain or be dry the next day. And so we can write T1 plus T2 equals 1. And so all we're going to do here is solve this system of equations like we would any other one from earlier on in the course. And so I'm going to start by taking T2 equal to 1 minus T1. And now I'm just going to substitute this over here in for T2 over here. So that will give me 0.25 T1 plus 0.5 times 1 minus T1 equal T1. So all we did is substitute in for T2, which gives us 0.25 T1 plus 0.5 minus 0.5 T1 equal T1. And then simplifying here, we see that 0.25 minus 0.5 is going to equal negative 0.25, and then adding it over will give us 0.5 equals 5 over 4 T1. And it might help, we can show you actually the in-between step here as well. That is just 0.5 minus 0.25 T1 equals T1, which will then go to 0.5 equal to 5 over 4 T1. And then we're going to just multiply by 4/5 on both sides, or divide by 5/4, which will give us, right over here, 4/5 times 1/2 equal to T1, which gives us 4/10 equals T1, or T1 equals 2/5. And so finally, we just need to find out what T2 is. So if we look over here again, we have T2 equals 1 minus T1, which is 2/5. So T2 is equal to 3/5, which tells us that T, our vector T, will just end up being 2/5, 3/5. And remember, we have rain and then dry, so the probability that it will rain on one day is 2 out of 5, and the probability on any given day that it will not rain is 3 out of 5. And so that's all we have, is that 2/5 of the days it will rain, and 3/5 of the days it will not rain.